Welcome to section 8.4 where we're learning about the hyperbola. The hyperbola is, it looks like this. Like it almost looks like parabolas, but it's actually got like a steeper, more V-like, but not quite V-like shape. And it looks like two of them facing away from each other. So we can see in the diagram here where there's all these other things that kind of make it so we to define it. But the actual graph is just those two branches. So to get the definition of the hyperbola, we want to understand that the hyperbola is a set of all points in a plane where the difference from two fixed points, called the foci, is a positive constant. So my foci, remember this isn't part of the graph, so I'll do it in gray. There's a foci here and a foci here, just like with a parabola has a foci that it hugs. The distance, this length, the difference between this A and B is constant no matter where you are on the foci. So that might sound kind of familiar. So all those differences would be the same. A minus B is constant for any point on the hyperbola. That might sound kind of familiar because we learned about an ellipse in the last section where we had two foci and we had the distance between the 2 point, any point that has the same sum, we were able to make a string and draw an ellipse around it, and the sum of those two string parts was constant all the way through. That was easier to visualize because it was a constant sum, and we could take one string length and draw a whole ellipse. The hyperbola is a little harder to visualize because it's a difference, but algebraically, it's a very similar definition. We have similar parts. We have the foci, we have the vertices. The transverse axis, which goes through the foci and the vertices, is analogous to the major axis of the ellipse. So a lot of similar algebra. The main difference here being that we're looking at the difference in those string segments instead of the sum. So let's look at the official definition here. The hyperbola is a set of all points in a plane, the difference whose distance from two fixed points is a positive constant. So any point, actually this blue line down here shows it well. Any 2 points, the difference between those two line segments, this little guy and this long one, is going to be equal no matter where on the hyperbola that point is. So that A and B difference will be equal to that first one, which will be equal to this one. So that's that set of points where the difference, I have a tack at the foci and a string going from the foci to any point on the line where the difference between those two string segments is equal. The hyperbola has two separate curves. Each of these curves is called a branch. So that's one branch and there's two branches. The 2 points where the hyperbola intersects the line joining the foci is called the vertices. So we have our vertices at the tip here. The line segment joining the vertices is the transverse axis. So remember with our ellipse, that was like the major axis tips, and now it's going to be the transverse axis, which tells us if the hyperbola is going to be horizontal or vertical. And the midpoint of that transverse axis, halfway between the vertices or halfway between the foci, is the center. All right, so I'm going to erase all my scribbles here so you can see that diagram in all its glory and neatness. And let's slide over here to our standard form equation of the hyperbola. Remember, for 8.1, we're focusing on it being centered at the origin. So if it's horizontal, that means the transverse axis is horizontal. Then you can see those two hyperbolas are opening left and right. And that happens when we have the x squared term in front, which means the x squared term is the positive one. Notice this one. A and B can be switched. Notice A and B, there's no rule like with an ellipse, A had to be larger than B. the size of A, B, and B, or the magnitude of A and B doesn't matter anymore. What matters is which one's positive and which one's negative. So whichever one is positive comes first, and that dictates the direction, if it's going to be horizontal or vertical. So since we're starting with x squared on this one, that x squared is the positive, the y squared is negative, that tells us it's horizontal, and it opens from left to right, left and right. As opposed to when we have the lead y squared, because the y squared is the positive term, this is positive term, that tells us that it's going to be vertical. So the transverse axis, when it's centered at the origin, is the y-axis, and it'll open up and down. All right. Our other variables are similarly defined as we've seen before in the ellipse. We have the foci starting from the center. You can go plus or minus c to get to the foci. Starting from the center, you can get to plus or minus b and plus or minus a to get to the vertices. Actually, yeah, plus or minus a. And then the b's, plus or minus b, would actually get you another point over here, which we'll go over in a little bit when we get to the graphing. So that, and another difference between ellipse and hyperbola that's important is this difference. You might remember from an ellipse was c squared equals the difference, a squared minus b squared. But for a hyperbola, it's the sum. So again, we're flipping that sign and changing that sign. I'm going to erase that so that doesn't cause confusion. So that's an important difference that we'll need later on too. All right, so let's get to 1 through 4 from your homework. I'm actually going to pull this box down so we can use this as reference. Doing those 1 through 4. So remember, our key terms here are our first term, the positive one, dictates the direction. So for number 1, our first term is the x. It's the x term. So that tells me that the I'm going to get a smaller pen so I can fit more information here. That tells me that the transverse axis is actually the x-axis. It's horizontal. And since it's centered on the origin, that's actually the x-axis. So that means we're looking at this situation. So we're looking at the horizontal along the x-axis, the transverse axis on the x-axis. So this hyperbola opens left and right versus up and down. So I know it's not A, and I know it's not C. So it must be B or D. So now to decide between B and D, I think, okay, what else can I look at? Okay, well, I can look at the vertices. The vertices is underneath that first term, which is 36. So I can really write that as x squared over 6 squared, because remember our A thing is squared over here. So we're going plus and minus 6 from the center. So we go plus minus the vertices at plus and minus 6. And we're going in the x direction because it's under the x. Vertices at x equal to plus and minus 6. And since it's centered at the origin, it's really just plus and minus 6. But plus and minus 6 from the center. The center is the origin, though. So that helps. So I'm looking at where's 6. Let's see, these are counting by 2. So that's 2, 4, 6. There's 6. So there's my vertice, plus and minus 6 right there. If I had looked at this one, that vertice looks like it's actually at 3. Negative 3 and positive 3. So that's not going to work for us, right? So for 1, we have B is our match. And I can find that from the transverse axis being horizontal. And I can see that the vertices are going to be at plus and minus 6 because of the denominator. As opposed to when I look at, I'm going to erase my scribbles here. So I can look at number 2. And I see now with number 2, that one starts with the y squared term, which means the y squared is the positive. So now my transverse axis is vertical. So it's actually the y-axis since it's centered at the origin, and vertical. So there's my transverse axis here or here, so it can't be up and down. So it opens, well, I'm sorry, I just said that backwards, didn't I? Sorry about that. The transverse axis goes through the vertices in the foci. Hopefully you were confused for a second. Like, why is she saying that? That's not right. That's the opposite of what she just said. You're right, it is. So our choices are, wait. Whoops, I did it again. Sorry, it's still the y. I changed axis instead. So it's still the y-axis connecting the foci and the vertices. Sorry. So this one, so it's going up and down. Starts with a y, so it's opens up or down. So it's not B or D. And under the y squared, I have a 36, which tells me y is going to be equal to plus or minus 6 for the vertices. So looking at A and C, I see my vertice here is at plus 6, and here is at minus y equal negative 6. Over here, it's a fraction, right? We're counting by 2's here, so that's like a quarter. So C is too small. A is our match then for number 2. Now I'll let you do 3 and 4 on your own. And I'll erase my scribbles. Just keep my answers. I'll keep my 6 there because that told us that this was the right one. And there's your intro to hyperbolas.